Let me start this.
Oh, what?
Okay, so we'll go through real quick, all right? Most of the matter around you is in the form of, that should be compounds. The properties of compounds are different from the properties of the elements that make them up. And if there's, any of this needs to be explained, let me know, okay? And that makes sense. You think of water, H2O, hydrogen's an explosive gas, oxygen's a flammable gas. They come together to form a liquid that's neither flammable or explosive, right? Okay, so they're different. Number 3, Na and Cl are symbols. Number 4, NaCl and NaOH are formulas. H2O is water. In the formula H2O, 2 is a subscript. Am I going too fast? Is this okay?
No.
Number 7, the formula HCl, the ratio of hydrogen to chlorine is 1:1. Number 8, the number 2 of the formula H2O says you have 2 hydrogens. Number 9, if a symbol in a chemical formula does not have a subscript, it contains 1. Doesn't make sense to be 0, right? Because you would have to put every element every time you write a chemical formula, every element on the periodic table, because there's a lot of zeros. Number 9, no. Number 10, in the formula Fe2O3, the ratio of iron to oxygen is 2:3. An atom is chemically stable if its outer energy level is filled with electrons. Number 12, for atoms of most elements, the outer energy level is filled when it has 8. Number 13, the noble gases, which noble gases are what group?
The far right.
Okay, group 18. Because they are chemically stable. Number 14, a chemical bond is a force. Number 15, chemical bonds form when atoms lose, gain, or share electrons. And then what about the table at the bottom? You want me to go over this too?
No.
Okay.
If it's a worksheet, can we just take a picture on our phone and send it to your email?
I want it sent on Canvas, and I can show you how to do that later on.
Okay.
You've got to put it, you've got to make it, send it to your Google Drive and attach it as a Google Doc,
Okay.
and give me access to it too.
Well, you can
do it directly.
You can just put it right in. If you go to text entry and then press on text entry and then scroll on like the above the letters, and you can go to like attach image or whatever.
So,
Oh,
show
I
him how
thought
to
you
do
could
that
only
today.
take a video.
And then if you do it on your phone, you can take a picture on Canvas. But
Yeah.
Yeah.
Oh, you can? Okay.
Yeah, well, if it's Canvas app,
If you
that
try,
is.
yeah, if you try
Okay.
to take it through your
Okay.
phone.
I didn't know that.
So show him how to do that today, somebody, all right?
What about
So, any questions about these ratios?
No.
That should be self-explanatory. Maren, is that all right? Do I-
Yeah,
can I
I'm
go
good
on that one? Okay. On the back, I mean, I can do all these diagrams too if you want me to, or we can just talk about how many dots you should have in them.
Yeah.
So, hydrogen should have 1,
Here, it's fine. I'll do it.
neon should have 8, sodium has 1, calcium has 2, aluminum has 3, fluorine is 7, argon is 8, potassium is 1. And then down here, why do sodium and potassium have the same number of dots in their electron dot diagrams? Well, they're in the same group, or they've got the same number of valence electrons. Either of those things will work. And then what does this tell you about the chemistry of these elements? They have similar properties, is what we'll say. Okay? And we talked about that last semester. Same grouping, similar properties. Rho does not. Any other questions? Okay. So on the next page in your comp book, write this in. So I don't have any labs to do this chapter. I do have a bunch next chapter, and we kind of have to go through this one to get to the next one. All right? So we're going to probably be done with this chapter next Friday and have a test over it the Monday after. That's what I have written down. That could obviously change. So it says, read pages 191 and 196 and answer 1 through 3. That 1 through 3 is on page 196. Okay? There's also 1, 2, and 3 on page 190, which is the first page you'll see on there. The questions we answer are always after the reading section. All right? So the objective here is to understand how to name compounds. I probably should have put how to name compounds and how to write formulas too. What we're really going to do today is kind of give you, we're just going to throw everything out there, make it kind of difficult, and then we'll back off and tomorrow we'll start doing it like a part at a time, okay? Remember, for the grades, it's mainly participation points. So if you will try on this, even if you might get home and be a little bit confused, if you'll try, you'll get the points. Okay? And I did have somebody last hour who was going through and looking up all the names and formulas on the internet, which, I mean, whatever. The problem is when you get to the quiz, there's no way that you're going to be able to do it. All right? And just like always, if you leave the page, you'll get a 0 on it. So try to do it, okay? So I'm going to go take roll and let you get caught up, and I'll have a couple things to talk about. I'm going to add some things to this because we didn't talk about cations and anions, but I'll simplify it, what we mean by cations and anions. So when we're naming ionic compounds or writing formulas for them, the ionic compound consists of the name of the ions that make up the compound. So the cation, we just write the name. The cation is the metal. So I'm going to put metal and put an arrow here, take cation. The anion is then the non-metal. Remember, the metal is always written first. So I'm going to write non-metal and put an arrow. So when we name the cation, we just write the name of the element. When we name the anion, we change the ending to IDE. So NaCl becomes sodium chloride. Okay, CaF2, which we talked about yesterday, would be calcium fluoride. All right? So naming ionic compounds is fairly simple. Now it becomes a little bit more complicated when we deal with transition metals. Because transition metals, remember, they're groups 3 through 12 on the periodic table. They have multiple oxidation numbers or multiple charges. Okay? So we have to say which metal we're dealing with. Okay? Which iron, or I think iron is the example I gave, yeah. Which iron we're dealing with. So iron can combine with oxygen 2 different ways. It can combine in a 1-to-1 ratio or a 2-to-3 ratio. Because iron can have a +2 charge, it can also have a +3 charge. So we would call this, we name it the same way, iron, but we put a Roman numeral after the iron to represent what the charge is. So iron 2 oxide, this one here would be iron 3 oxide. If it's not a transition metal, we don't need to we're not going to put Roman numerals. It's incorrect to do that, okay? So you only put Roman numerals on transition metals. For covalent compounds, we do it a little bit differently. On covalent compounds, and I'll give you all the prefixes, but we give a numerical prefix to tell how many atoms of each element are in the molecule. So everybody knows CO2 is what?
Carbon dioxide,
carbon dioxide. CO would be
carbon monoxide.
Carbon monoxide.
carbon monoxide, okay? And so we put down here, if there's only one atom of the element, it does not get a prefix. Now, that only works for the first element. I should have put that in there. So I'm going to put an arrow there and say only for first element. So the only time you wouldn't give a prefix is if the first element only has one. So CO2 is carbon dioxide. CO is carbon monoxide. Okay, if there was a 2 in front of the carbon, which there wouldn't be, okay, but you would call that dicarbon dioxide, which doesn't happen. All right, but
So
just to give you an example.
could water be dihydrogen oxide?
Yeah.
Oh, that's
Mhm.
weird.
Yeah, that's the actual technical name for water. Okay, now I'm not gonna trick you on that. Okay, but it would be dihydrogen monoxide is what it would be. Just like we call NaCl, the chemical name is sodium chloride, but the everyday name is salt. And so a lot of things have an everyday name that we use for them. And we still change the ending of the second element to IDE, okay? So we change oxygen to oxide, or we change fluorine to fluoride. So I've got a couple of examples down at the bottom. BF3 is boron trifluoride. Remember, we don't have to put a mono in front of the first element if it's one, okay? That's the only time it doesn't have a prefix. And then N2O4, which was one of the questions from yesterday. Let me move it up a little bit.
I just can't see on the computer.
Okay, I'll move it up, but it's gonna mess up my arrows.
Okay.
That's all right, right? I'll change the arrows, how about that? I'll do this. Okay. So once you get all that in there, go ahead and pull that up on Canvas. And so once everybody gets that down, I'm going to give you the table of the prefixes to write in your comp book. So you always have it, you don't have to memorize it, okay? And I'll give you up to 10. We won't use all 10 of them. We'll really just use mainly the first 4. But that way you've got them.
Do we go to compound name and formulas?
Yeah. So there should be 2 things. I think the worksheet I gave you is the naming worksheet 1. Should be the only other one opened up on there. And I'm going to talk about that worksheet here in a second too, because we're not going to do all of it. Okay, and we're not going to submit all of it either. pull it up from there. Yeah, I can see there. Okay. Yeah. And I put two things on there. One of them's the book. The other one is like a flow chart for how to name things. If you wanna look through that.
What is BR?
Bromine.
How do you spell that?
It should be on, you still have this.
I don't have it. I don't.
Didn't I give you one yesterday?
No.
Does anybody need to figure that table?
Can I?
Okay, can I give you the table of prefixes? Everybody done with the notes?
Yeah.
Okay, so. So let me turn or move this over to here. And I'll zoom in on it. How's that? Is that big enough? And this is on that flow chart too that I attached. And if you want to print that flow chart off and put it in your comp book, you can. I don't know, some people think it's not very helpful.
So do we draw this in?
Yeah, just write this in. So I've got some, there's some blanks in here. So one obviously is mono. What's two? What did we just say two was?
Bye.
Di.
Done.
Okay, di. Three is tri. What about four?
Quad.
It's not.
No.
Tetra. Five is penta. Six, any ideas? Somebody said that. Hexa. Seven is hepta. Eight, octa.
Isn't this just the start of like shapes? Like a hexagon has.
Yeah.
Octagon has.
Why'd they change, why'd they do tetra and di instead of just bi?
I don't know.
Yeah.
And then 10 is deca. So some of them are a little bit different.